Let me put this plot here again. And suppose this is sometime t1 and this is sometime t2. And I have measured x and my particle has done something like this, let's say. Okay? So here is x of t1 and here is x of t2. For example, t1 is, let's say, 9 o'clock time now, and my particle is at position 2.5 meters. So x of t1 is 2.5 meters. Then I look at my watch again at 1 minute past, or let's say 1 second past 9 o'clock. Okay? So T2 is 1 second later. And now I find my particle is at 5.3 meters. So x of T2 is 5.3. Okay? Now what is the velocity of the particle? Velocity is the distance it has gone divided by how much time it took it. Okay? So velocity is just, let me introduce some notation. Delta x divided by delta t. This is the Greek letter delta used to mean difference, the change in something. Okay? So the difference in the particle's position divided by the difference in time, the time interval, of course, gives me a velocity. Velocity, in general, is a vector. It has a direction. So in one dimension, velocity, I use the term velocity because the answer to this could be plus or minus. The particle could be moving to the right or to the left. Okay? Just the magnitude of velocity, how fast it's going, I use the term speed. Okay? By the way, all the new terms, the Turkish equivalents of the terms, are given in the new version of the draft notes. There's a glossary, a little dictionary that gives Turkish equivalents. So if you don't know the meaning of a word, you can check from there. If you notice a word, a term that's important and we have forgotten to put it in the glossary, please tell me, because I'll update it. Okay? Now, let's continue. What is delta x? Delta x is x of t2 minus x of t1. The later position minus the earlier position and divided by, what's delta t? T2 minus t1. Okay? And let me indicate these quantities on the graph. Here is your delta t. And here is your delta x. Okay? Now let me indicate something about this velocity on the graph. Let me draw this line. It should be a straight line. I'll try to make it straighter. Okay. Now, if the particle is moving fast in a short delta t, it will move a long distance. So delta x will be large and delta t will be small. And this green line will be steep. Whereas, like in this example, if in a long time interval delta t, the particle only moves a short distance delta x is small, then the ratio delta x over delta t, the velocity will be long. Geometrically on this figure, delta x divided by delta t is just the steepness, the slope of that line. So if you draw x of t as a graph, and for t1, t2, x of t2, x of t1, you calculate this velocity, that velocity shows up as the slope in of the line between x of t1, and x of t2, t2. And in this graph, the faster your velocity is, the steeper the graph is. Okay, so that's the way to see geometrically whether the particle is moving fast or slowly. Okay? And now let us look at this graph. Is this the exact velocity of the particle? Between time t1 and t2, particle is moving along, and I'm making some measurements. Now I'm trying to calculate what is the speed. Between t1 and t2, the particle is not always moving with the same speed. And you can see this on the graph. If between t1 and t2 the particle was moving with the same speed, its trajectory would be just this, because at any moment it would have the same slope. Okay? But here you can see that at the beginning, at t1, the particle is moving slowly. If instead of this t2 I had taken a time t2 was were here, then I would measure a much lower velocity. Whereas here, it has a bigger slope. If t1 was here and t2 was here, I would measure this velocity. It started slow and became faster and faster, as you can see on the graph. So this green line is not the true velocity at all times between t1 and t2. It is an average velocity that describes the motion for the whole interval between t1 and t2. Okay, is this clear? So this calculation gives me only an approximate result. Right? Now, suppose I'm really interested in knowing the velocity at time t1. For example, t1 is 10 seconds. Bu sınıfta bulunmanız gerekli değil. Bulmanızın tek sebebi dersi izlemek olmalı.